All right. Good afternoon.
Good afternoon, Dini.
How are you?
Fine.
Okay. Thank you so much for joining early. I'm so sorry I cannot use the virtual background
Oh,
here.
sorry. Let me turn on my camera.
Yeah. Thank you. Thank you so much for using the
Thank you.
virtual. Because I cannot use it in the office. My face get very white. I think
Oh, it's
it's
because in the background. I think it's the background.
Selamat siang. Good afternoon, Ibu Delila, Miss Delila. Can you hear me, Miss Delila? Okay, while waiting for Miss Delila, can you please try to share your screen first, Professor Cesar?
Okay, I will try.
Yes, I can see the screen. Yeah. Thank you.
Thank you.
Have you shared the invitation to your student?
Yes, I have shared it to them this morning and yesterday. So
Yesterday. That's great. Thank you. Miss Delila, can you hear me? Okay, maybe she's away. So how's the weather in the Philippines?
Oh, now it's sunny, but there's unexpected rain around this afternoon.
Okay, that's great. That it's sunny. Yeah, it's been raining for the past few days.
It's also here, same thing. We experienced rain since I think Sunday up to yesterday.
Yeah, since Sunday, I remember.
Yeah. This is the first day that we have, I think, the full sun being available in the sky. But there's unexpected rain shower this afternoon.
In the evening, maybe.
Yeah.
Okay, that's great.
So we are also experiencing a change in weather because now is the change in the wind direction.
Mm-hmm.
Yeah, so it's more. Before we have a very warm air being experienced here, but now we are experiencing colder air.
It's actually the same in Malang. Before, during like I think June until November, it was sunny throughout, and it was very hot, even hotter than the last year and the previous years as well. This year has been like very hot, but once the rainy season start, that's it. It will rain nonstop.
Oh. So actually, in our country, the months of June up to like October, it is the rainy season here. But most of the time, the typhoon that is passing through would pass at the upper portion of the Philippines, like the area of Luzon. But during late October down to like December and January, the path of the typhoon is in either in Visayas or in Mindanao. So we are expecting actually a lot of typhoon that will be passing in our area starting this month.
That's scary. The typhoon.
Yeah. And most of the strong typhoons would really occur in this month. Remember the Haiyan? Haiyan occurred sometime in, I think, around October or November. That's the path is this area, the Visayas.
But since you've been experiencing typhoon for so many years, I think most of you, like all the people in the Philippines, they already get used to it. So when they know that typhoon is coming, they be prepared for it.
Yeah, there's a lot of free typhoon evacuations that's happening in area, especially those low-lying areas, they would move the residents away from the area.
So during typhoon, is it all of them need to move somewhere?
Not all, but though we have identified actually vulnerable areas. So those residents of vulnerable areas are the ones that are evacuated.
Evacuating, yeah. Okay.
But still, there are some that are very stubborn. They will not move.
Yeah.
They will not move because they are afraid that they will somebody will steal
their belongings.
their
Yeah.
belongings or their livestock.
Understandable. Here in Indonesia, it's also the same.
Same.
Yes, actually, the government trying their best to protect the people, but yet they still don't want to move or they don't want to be evacuated. They just want to stay there.
Yeah.
Even during the volcano eruption here, some like the most frequent, what do you call, the force major is the volcano eruption, because we have a lot of volcano. But even though there are a lot of government will make like an announcement, be careful, there will be a volcano eruption, you need to be move somewhere, but they just want to stay there.
So in our case, we are lucky that the volcano was in the other island. Because in Panay, we own the in Panay Island we don't have volcano, but our neighboring island, the island of Negros, they have one active volcano there, the Mount Canlaon. So sometimes it becomes active that people are also being moved away from the danger zones.
Yeah. So in the Philippines, you have all sort of, like, you have volcano, you have the ocean as well. So it's all actually similar with Indonesia, except the typhoon.
Yeah, the
we
typhoon
don't
is
have the
very.
typhoon. Yeah.
It's very dangerous if you are living in the area on the side of the Pacific Ocean, like the outer side of Visayas. So that's the area that is always hit by strong typhoon, because they are the first one to be landed with when the typhoon comes to the Philippines, because they are in the side of the Pacific Ocean. So they always carry the brunt of the typhoon. So when Typhoon Haiyan struck the Philippines, most of the death occurred in that area. Because it's an open ocean, so typhoon could really build its strength. But in our case, we are in the inner portion, in the inner part of the country. So before the typhoon can hit us, it already landed on several islands. So the strength
has been reduced a lot.
It has diminished. But still, Typhoon Haiyan is really the worst, because even though it has landed 5 times already, the strength is still more than 250 kilometers per hour.
Wow, that's dangerous still. Yeah. Okay, we have Miss Delila here joining us.
Good afternoon.
Delila, you are still in mute, Delila. Good afternoon, Miss Delila.
Good afternoon, Miss Didi.
Yes, Professor Sesa is here already. He has already, yes, checking the PowerPoint now. Can you please share your screen?
Oh.
Mhm. Yes, I can see the screen. Please make it full screen. Yes, very good. Thank you. Okay, I will begin the class in 1 p.m. sharp. So another 6 more minutes. Thank you. So this is the last class, actually, last of 7 classes.
Oh,
Mhm. Hopefully next year we can do this again.
actually, we are, because
Mhm.
after this, we also have another activity.
Yes, what is it?
That's about we are actually conducting a lecture series on
Mhm.
flexible learning.
Flexible learning,
Yeah,
interesting.
so
Mhm.
it's a project of our Department of Education.
Oh, Department of
It's,
Education.
yeah,
Okay.
in the tertiary level, and
Mhm.
our trainees are professors from other universities
Okay.
in Island.
Mhm.
We will have our graduation after
Oh,
like
yeah. We already had our graduation last week, and yeah, that's why it's been a very busy week and
yeah.
busy month as well for us. So when is the midterm test on your side?
That will be, I think, first week of November.
Oh, okay, it's the same actually here as well.
Like
So we will
after,
have, yes, 2 weeks, 2 first week of November, and
yeah.
then yeah, continue all the way until Christmas.
Oh,
And yeah.
yeah. Yeah, our final exam is around, I think, December 18.
Oh, okay, earlier, slightly like
Yeah,
earlier.
because we only have three major
Mm,
examinations.
mhm.
Having our final exam at May 18, and
Mhm.
then we will have our enrollment, I think, second week of January.
Mhm. Miss Delila, have you shared your link to your students? The Zoom meeting link?
John Miss ini
Done already.
waiting
Okay.
room ini.
All right. Can you please share it to the Prodi as well, Pak Dani? Maybe, or which Prodi are you from? I'm not familiar.
Electrical Engineering, Pak Subairi.
Oh yeah, please share it to
Bisa
Pak
sampai.
Subairi. Yeah, so he can share in the Prodi group.
And Miss Delila, I think your screen is like the other way around. Maybe you just accidentally mirror your screen. It's like mirroring because you know the writing is the other way around. Just unclick the mirror my camera. Ah, okay. It's good already. All right, I will start now. I will admit all the participants. Hello, everyone. Good afternoon. Greetings from University of Merdeka, Malang. I hope all of you are doing well. My name is Andini Rispandini. I am your moderator for today's International Collaborative Teaching with the topic of development and implementation of 3D printing technology and renewable energy to supply rural community needs. This event is proudly presented to you by the collaboration of Office of International Affairs, Faculty of Engineering from University of Merdeka, Malang, and Central Philippine University. Please allow me to extend our warmest greetings to the Dean of Faculty of Engineering from University of Merdeka, Malang, Professor Agus Suprapto, to the Dean of Faculty of Engineering from Central Philippine University, Dean Danny Molina, to the Head of Office of International Affairs from Central Philippine University, Ms. K. Adengayo, MED, to the esteemed speakers of today's International Collaborative Teaching, Ms. Delila Cahya Permatasari, S.Tr.T, M.Tr.T from University of Merdeka, Malang, Professor Cesar Rico S. Acanto, Asian Engineering EE from Central Philippine University, to our students from the Faculty of Engineering from University of Merdeka, Malang, and to the students from the Faculty of Engineering from Central Philippine University. It is my pleasure to welcome all of you to this International Collaborative Teaching. Please be advised that all of our lecture series can be found in our YouTube channel at OIA Unmer. For all the participants, we will have the Q&A session at the end of each presentation. Please kindly type in your questions in the Zoom chat box. Kindly state your name, where do you come from, and followed by your questions. Now, as we have come to the main event of this lecture, please welcome Ms. Delila Cahya Permatasari, S.Tr.T, M.Tr.T from University of Merdeka, Malang. Without further ado, Ms. Delila, the platform is yours.
Thank you, Miss Dini. I will share screen.
Yes, go ahead.
Okay, thank you, Miss Dini, for the opportunity. Now, in this time, I will share to you all about my knowledge, development, and implementation of 3D printing technology. In this session, I will explain about definition of 3D printing, working principle of 3D printer, process of 3D printing, and last implementation of 3D printer in University of Merdeka Malang. What is 3D printing? 3D printing is also known as additive manufacturing, a method of creating a three-dimensional object layer by layer using a computer-created design. 3D printing is an additive process whereby layers of material are built up to recreate a 3D part. And what is additive manufacturing? Additive manufacturing, or EM, is the industrial production name for 3D printing, a computer-controlled process that creates three-dimensional objects by depositing material, usually in layers. Next is working principle of 3D printer. There are 3 steps. First step is modeling. Modeling takes virtual blueprints from modeling software and slice them into digital cross-section for the machine to successfully use as a guideline for printing. Second, the process is printing. The machine reads the design from computer-aided design and lays down successive layers of plastic filament to build the model. After printing process is finishing object to be polished to get the final product and remove support if there are any. You can see the picture. This is the modeling with computer-aided design, and second is process printing, and last is finishing the object. How does it works? As I mentioned before, the first step of any 3D printing process is 3D modeling. To maximize precision, all objects have to be designed in a 3D modeling software. That's where computer-aided design or CAD software comes in. Modeling allows printer to customize their product down to the tiniest detail. The 3D modeling software's ability to allow for precision design. Then, after design in computer-aided design, save the 3D design from CAD software in .stl file. STL is stereolithography, a form of 3D file most commonly used in 3D printing. After save the format in STL file, it's time to slice. Slicing the model. Engineers need to slice the model into layers in order for the printer to create the final product. Slicing software takes scans of each layer of a model and will tell the printer how to move in order to recreate that layer. When the modeling and slicing of a 3D object is complete, it's time for the 3D printer to finally take over. Then the object is finished. This is the example of 3D object. Computer-aided design software. CAD, or computer-aided design software, is the use of computer-based software to aid in design process. CAD software is frequently used by different types of for engineers and designers. CAD software can be used to create two-dimensional drawings or three-dimensional models. Here are the list of the most used CAD software programs. First is SolidWorks, second Autodesk Tinkercad, third Autodesk Fusion 360, and fourth FreeCAD. Here is computer-aided design software. Next, slicing software. Slicing turns digital 3D models into G-code. What is G-code? G-code is a generic name for a control language that a 3D printer can understand. 3D G-codes contains instruction for the 3D printer. In other words, G-code tell the 3D printer how to print the model, but without G-code, 3D printer is useless. Basic slicing software create paths for a 3D printer to follow when printing. These paths are instructions for geometry, and they tell a 3D printer what speed to print for various points. Here the list of the most used slicing software programs. First is Ultimaker Pura, Idea Maker 4.0, Simplify 3D, Prusa Slicer, and we can use Slicer G-code generator. You can see the picture. This is the part of 3D printer. There are motor stepper, and here is extruder. Then below is head bed or bed plate, and this is a display LCD, motor stepper, two move extruder. This is the basic part of 3D printer. Next, the motion of 3D printer. There are three axes making up the 3 dimension: the x-axis, y-axis, and z-axis. The x-axis refers to left and right movement. Y-axis refers to forward and backwards movement. And then z-axis refers to up and down movement. A printer such the Engr is known as a XZ hot end and Y bed printers. This means the hot end assembly move along the X and Z axis, left, right, up, and down, while the bed move forward and backwards on the Y axis. (3D printer filament). 3D printer need materials to print the 3D object. In this case, this printer uses plastic filament for print the 3D object. What is filament? Filament is a thermoplastic feedstock used for 3D printers. You can see the pictures. This is the roll of filament, plastic filament. And what kind of plastic filament? First is PLA. Is an acronym for polylactic acid. PLA is suitable for complex prints and is particularly common in prototyping and architectural mock-ups. It's also usually the standard printer filament for user new to 3D printing. Second, ABS filament. ABS is an acronym for acrylonitrile butadiene citrine. ABS is one of the first plastic to be used for 3D printing. Third, HDPE is an acronym for high-density polyethylene. HDPE is gaining popularity as a 3D printing material because it's easy to transform into new material through recycling. There are many colors for filament plastic, and this is the object 3D. Next, the result of 3D printer. We are focusing in electrical engineering, so the implementation 3D printer to print part of robot. This is gripper robotic. This one, and this is arm robotic. This one arm robotic, robotic. This robotic parts is from 3D printer product. Next, implementation 3D printing in Department of Electrical Engineering, University of Merdeka Malang. In Electrical Engineering University of Merdeka Malang, we use 3D printer with model Creality Engr 3v2 and other specifications such as maximum print size, maximum object to print 220 times 220 times 250 millimeters. The number of nozzle, just one, with diameter nozzle 0.4 millimeter, and filament, the type of filament use ABS. ABS have temperature hotbed 100 degrees Celsius and temperature nozzle 240 degrees Celsius. Display using LCD. Next, I will explain step for process printing. We use SolidWorks software to design 3D. For example, we design Arduino box. Arduino is microcontroller. After we finish design of Arduino box, we save the file to STL format. We save, then we open slicing software. In Electrical Engineering University of Merdeka Malang, we use Ultimaker Cura. This is the model of Arduino box. We can see the size of object, x-axis, y-axis, z-axis. After that, we choose standard quality. Next, we setting the temperature. We set the temperature printing because we use ABS filament. Printing temperature is 240 degrees Celsius. Then wet bed or bed temperature is 100 degrees Celsius for ABS filament. Then we choose material ABS and nozzle we use in 3D printer Creality. Nozzle size 0.4 millimeter nozzle. Speed we use for print is 50 millimeter per second. Then we click slice. Next is slicing processing. Then we know the process to print this Arduino box need 4 hours and 7 minutes. Then we have to save to micro SD and the format become G-code. After that, we insert the micro SD to port in 3D printer, and in display LCD of 3D printer, we choose print. Then we choose the file Arduino box G-code. Next, processing of printing. In right picture, in this process, filament of solid thermoplastic material is pushed through to heated nozzle and print layer by layer based on 3D model. And the result of 3D model Arduino box Here you can see this is Arduino microcontroller. We print Arduino box with filament type is ABS. We can print other objects like car toys, then cat toys, frame robotics, battery box, keychains, and many more. This is the result of object from 3D printer in Electrical Engineering, University of Merdeka, Malang. Thank you for your attention. Next, my colleague student will explain video about processing of 3D printing to print parts of robotics.
Okay, thank you so much, Ms. Delila. And our student Dionysius will continue the presentation. Please go ahead, Dionysius. You may share your screen now.
Okay, thank you very much for the time given to me. First of all, I want to introduce myself. My name is Dionysius Arul Islami. I am from University of Merdeka Malang, Electrical Engineering Department. So I am responsible in robotic team in electrical engineering. So in this section, I am going to show you the demonstration of using 3D printer in real time. So I will share screen my video.
Mm-hmm.
And can you see my screen?
Yes.
Okay. So as you can see,
yeah.
okay. So as you can see, this is the 3D model of the parts of robot. So this part is actually very small, but it looks detailed like this. After we make this model, we save the files to STL part. Okay, like this. And then we can just open the STL file using program called Ultimaker Cura. Okay, so this is the Ultimaker Cura software, and this is our 3D model. However, the orientation is incorrect, so we need to rotate it to the correct position, like this. All right, and then we can just check the size. It is already correct. So we can jump to material. The material is correct. The infill is correct, 20%. And the support is correct too. So we can just leave everything like normal. And then we can start slicing the 3D model into G-code. After the process is finished, you can see that there is a time duration, how long the printing process will take. So we can just save the G-code files to our disk. After that, we can just go to our 3D printer. So this is our 3D printer. So let's select our files, this. And then we can just wait the 3D printer to start. However, we need to wait until the temperature reaches the desired temperature. And then the printer will start. So this is the process of 3D printer in real time. However, the process will take a lot of time. So I will speed it up. Okay, so this is the speed up version. So like the specification say, it will take about 30 minutes. And this is the result of 3D printed model. sometimes it's very hard to pull it out. So I recommend to use alcohol. And this is the final result after finishing. It looks smooth, it looks good, and it is applicable to our robot. And this is the other models that I made too. And this is our robot. As you can see, the application for our robot is on its legs. And we place it like this so it can move beautifully, move smoothly. And trust me, it is very strong, so it won't break easily. Okay, so I think that's all about the demonstration of using 3D printer in robotics department. Thank you very much for attention, and I will give it back to moderator.
All right. Thank you so much, Dionysius and Miss Delila. Very interesting presentation about 3D printing. Can you tell me what are the things that you created using that printer so far? Is it robot only?
Currently, it is robot only.
Robot
And sometimes we made a third-party project like phone holder, and like Delila said, it's box Arduino.
A box of?
And then
Box of Arduino. Arduino is
microcontroller in electrical engineering.
Oh, it's a microcontroller. Okay, very interesting, and it should be very useful, right? Okay.
It is very useful. Yes.
And while waiting for the questions from the participants, please don't be shy. Please ask your questions to Ms. Delila and also to Dionysius here. They will be more than happy to answer your questions about 3D printing. Okay, maybe they are still thinking about the questions. Okay, I will continue with the next presenter first with Professor Cesar. After that, we will have a longer Q&A session at the end of our class. Okay. All right. Thank you so much, Ms. Delila, once again, and Dionysius for a very insightful presentation about 3D printing technology. Next, we will listen to the lecture by Professor Cesar Rico S. Acanto, Asian Engineering EE from Central Philippine University. Professor Cesar, the platform is yours.
Good afternoon, everyone.
Good afternoon.
So this afternoon, I will be presenting to you the experience of our department in implementing renewable energy projects to supply the needs of rural communities in our area. So I am Engineer Cesar Rico Acanto, a registered electrical engineer and also Master of Engineering and also an ASEAN engineer. And I also am the department head of Electrical Engineering Department of our university, Central Philippine University. So my topic this afternoon is about the implementation of barangay electrification program. This is sometimes in early 2000, and the outline of my discussion will be based on the following topics. First, I will discuss the introduction of how the project came into life, and then I will discuss about the barangay electrification program, the outcome of the program in the community as well as in the university, its impact to the recipients, and finally, I will have some conclusive statements. So to start with, let me introduce first our country, the Philippines. So the Philippines is an archipelagic nation composed of 7,107 islands. So compared to Indonesia, which you have 17,508 islands. So it's like roughly twice the size of your country. So our country has three major island chains, namely the Luzon area, so it's over here. And then we have the Visayas, it's somewhere in the middle, and then the Mindanao area, which is at the bottom here. So in terms of interconnection of electrical grid, it is very difficult to interconnect this whole island chain because of so many islands that is composing the country. So currently, we only have Luzon and Visayas area that are interconnected by our electrical grid, and then the Mindanao area has an isolated standalone grid. Okay. So next is, let me also introduce to you our area of implementation, which is the Panay Island. So Panay Island is actually part of the Visayas Island group and strategically located in the middle of the country. It is composed of 4 provinces, namely Iloilo, Aklan, Antique, and Capiz. So most of the road networks in our island is found in the area of the seashore. No? So it's along here. It's in the area along the seashore, so somewhere here. And there are few infrastructures, no, road networks in the middle. So because of the trend, no, in construction of our electrical system that it follows the road network. So the middle part of our province or our area, most of them are not connected to the electrical grid. Okay, so that is the primary problem, because that is why we have this rural electrification that is being implemented to supplement these areas now with electricity. So next, let me introduce also to you our school. So our school is named Central Philippine University. It is found in Iloilo City, and it was founded in 1905 by an American Baptist missionary. It is a 24-hectare campus. As I have said, it is located in Haru, Iloilo City, Philippines. So CPU is our school, and it is part of the implementation of barangay electrification program. However, the main proponent of this program is actually our DOE, or the Department of Energy. So this is the agency in our government which is responsible for the management of the utilization of our energy resources in the country. So another entity that is connected to the DOE is the AREC. AREC stands for Affiliated Renewable Energy Center. They were established in 2000, in late 2000, in cooperation with different higher learning institutions in the country. So at the start, there are actually around 32 RX, all around the country, which is responsible for implementing the um, the programs of DOE in rural electrification. Okay, so next we have the CPURX. So CPURX is one of the renewable energy centers established by the Department of Energy. So it was established in December 1989 under the College of Engineering Central Philippine University. So the main objective of the center is to introduce, transfer, and encourage the utilization of technically and economically viable renewable energy systems, or RES, throughout the Western Visayas region. Okay. So what is the task of CPUREC? So CPUREC is engaged in the design, fabrication, and installation of solar charging station, as well as micro hydropower projects for the electrification of remote barangays in Panay and Guimaras. It is also involved in wind and other renewable energy systems. So the center has developed its own design of different types of turbines such as cross flow, axial flow, and we have also created Frances turbine. Local materials and expertise are being utilized in the implementation of the project. Okay, so these designs are fabricated turbines were used for the most microhydro projects of the center that has implemented. Aside from turbines, the center has designed also and implemented rice hull-fired kiln, biogas digesters, and solar charging stations. The center continues to improve these designs to ensure reliability, efficiency, and sustainability of the renewable energy system projects. So the bulk of the project implemented by CPUREC is in the rural electrification under the Barangay Electrification Program. This initiative was initiated from 2000 to 2009. It aims to provide electricity to off-grid communities of the country. So at present, the center has implemented 79 BEP or Barangay Electrification projects composed of 34 micro-hydro systems and 45 solar charging stations in various communities of Panay. This benefited more than 4,000 households utilizing clean and renewable source of electricity for lighting and other applications. So we have here one of our last project that was implemented. This is in the province of Antique, and this project was actually funded partly by the Japan International Cooperation Agency or JICA. So how does a BEP project implementation work? So there are actually several steps we follow when we implement BEP projects. So this starts with the site identification and resource assessment, followed by the feasibility study and proposal making. Then design will follow, and then the procurement, the fabrication, and the installation. So during the installation process and until it is finished, and even after it is operating, project monitoring is being done by the center. Then project management and operations are also taught to the recipients of the project, and then from time to time, we suggest socio-economic development, which can utilize the renewable energy system that was put up by the center in the area. Okay, so let me discuss to you the different steps in our BEP program. First is a site identification and resource assessment. So site survey are done initially based only on the identification of the RE resource in the area. So a one-time measurement and assessment of the elevation, flow, and other relevant site characteristics for microhydro systems are gathered during this phase. Interviews with the residents are also conducted to determine the history and characteristic of the site with regards to the regularity of water supply, water use, flooding, soil erosion, water use, and among others. Once a particular site is identified as a potential site, a detailed survey follows for final site selection of the different components of microhydro, such as weir, channel, forebay, penstock route, powerhouse, transmission, and distribution lines. The suitable site for the solar charging station requires area without trees or other structures that can shade the solar panels. So its location must also be accessible to the recipients of the project. Normally, this is situated at the center of the community. And this stage involves direct personnel of the center as well as the study leaders. Their expert assessment and suggestions will be the basis for the final site selection. So here, what we are actually doing here is conducting a water resource survey for one of our projects in the province of Antique. Next is the feasibility study and proposal making. So data gathered during the preliminary and detailed survey are processed to determine the technical feasibility, economic and financial viability, as well as social acceptability of the project. So in most cases, we would inquire this to local government unit of the area. So after which a project proposal is developed in accordance with the funding agency's guidelines and requirements. So in this case, the funding agency is the Department of Energy. The proposal is prepared by the center staff and validated by the project leader, technical head, and the study leaders. Once a review is done, it is submitted to the funding agency for processing. Next is the preparation of design. So system design is generally customized based on the unique characteristic of its site, particularly if it is a microhydro site or a microhydro project, it is very site specific. So generally, the following factors are considered. Number one, use of indigenous or local materials. Number two, utilization of local manpower. Third, efficiency. Fourth, durability. Fifth, the reliability, and we have also the ease of operation and maintenance, modularity, and aesthetics of the system. So in most cases, we don't have heavy equipment when we implement this project. So involvement of the community is very important to us. So for microhydro systems, a computer program developed by the center is used to design the turbine and aid in penstock sizing for maximum power output at the least possible cost. The computer-generated pattern are also used for fabrication of important and irregular shaped parts of the system, especially the turbine. So civil, mechanical, electrical, and electronic designs are reviewed and validated by study leaders and consultants from the corresponding departments of the college. By the way, in the College of Engineering, there are 7 programs that we offer. So we have electrical, civil, mechanical, electronics, we have chemical, we have packaging, and software engineering. So in most cases, they are involved in the preparation of the design. The number of panels to be used in solar charging station is dependent on the number of beneficiaries in the area. Number 4, or the fourth step, is to do the canvas and procurement. So canvas are usually made for purchases less than 500,000 pesos, or that is roughly around 8,600 US dollar. So if you have this cost, you need to do canvassing. But below this, you can purchase it directly. So this is the fastest and the most convenient process where suppliers are competing for a lower price and deliver the items at specified date. Bidding is seldom experienced, so this is usually made for purchases requiring more than 500,000. This entails a longer time frame for the publication of the notice for bidding up to the delivery of material. Next step is the fabrication. So critical components of the system such as frames, penstocks, turbines are fabricated locally with the care at CPU ARIC using the skilled worker in our center without using sophisticated equipment. So we call this type of manufacturing process as backyard fabrication. Commonly used tools and equipment include oxyacetylene torch, lathe machine, welding, drilling, and grinding machine. So no high-tech equipment is being used so that when we go into the community, even the community people can learn how to do the repair, no, because the parts are made using local tools and common tools. Runners can be standardized without range, but most turbine fabrications are customized based on the site design capacity. Electronic load controllers are also fabricated by the faculty and staff members together with the students of the college electronics laboratory. Other system components can also be fabricated on site. So this is especially true if the part is too big to transport or it requires specific dimension and consideration. The next step is the installation. So since most of the project sites are located in remote mountain or mountainous area of the region, installation becomes a real challenge. Materials and components are designed to be modular to facilitate transport and installation. For example, wind turbines and frames are designed to be detachable and are assembled on site. Safety of workers during the project implementation is always a priority, especially on high and medium heavy systems. Ropes, cables, ladders, and sometimes animals are used to transport materials and even personnel for workers. Teamwork between CPUR representatives and local residents plays a vital role in providing willing and able manpower. So as you can see here in the picture, the workers here are the community people. We don't hire outside experts or outside workers, no, in a project on the community. So there will be no what you call this there will be no conflict, no, between the workers and the community. So this is what we call the Bayanihan spirit, where all join hands to make a challenging task possible. So by involving the local residents, they too give a sense of ownership of the project. So students taking up electrical engineering and electronics engineering are actively involved in doing the electrical wiring, powerhouse, and charging station installation as part of their outreach program. Okay. Next is the project monitoring. So in project monitoring, feedback and reports are used for project monitoring, usually made by the partner organizations like the Barangay Power Association or the BAPA, the local government unit or the LGUs, or even non-governmental organizations or NGOs. Scheduled project monitoring is arranged by the CPUREC to check the project operation and financial status. Project impact assessment is also conducted by partner organizations to evaluate the overall significance and effect of the project to the community. Okay, next is the project management and operation. So the establishment of Barangay Power Association in the community is necessary to operate and manage the project. So BAPA officials are trained in simple financial management, such as tariff collection and bookkeeping, operation and maintenance, household wiring, and troubleshooting with the help of the electrical engineering department and the Technical Education and Skills Development Authority or TESDA, and the local government unit. In terms of utilization, the recipient community members undergo load management training because normally our project is very small. No? It's not that big compared to the grid power available. So they have to manage their load so as not to overload the system. This allows them to maximize the utilization of the limited supply of electricity while prioritizing important loads such as the lighting. And next is the socio-economic development. So electrical power produced by the project is used for livelihood programs such as fishing, livestock and poultry raising, rice or grain milling, handicraft, and furniture making. Communal refrigerators are sometimes used for food storage and vaccines that help improve the health services in the community. Communal lighting facilities are also introduced to help improve the peace and order situation of the area. School lighting, sound system, and communal TV facilities help improve the entertainment and educational standard of the students in the remote places. Okay, so with all of these things that were done during the uh, electrification program, how does this impacted, or what is the result of it in the community, in the school, and even in the government? So let us look at the outcome of the project by the numbers. First, let us look at the location or the number of projects that were implemented. So the BEP program has resulted in 79 projects implemented by CPO-AREC all throughout Panay. So as you can see here, these are the numbers by provinces. So we have Aklan, Antique, Capiz, Iloilo, and Guimaras. The summary of project implemented per province is shown in this table. It can be noted that the concentration of BEP project is in Antique and in Iloilo. So most of the projects are in these two provinces. In Antique, these projects are in the mountainous area, while in Iloilo, it is mostly in the northern part. So the budget of each project is dependent on the type of system to be installed, the capacity, the geographical location, and the type of structure to be built. Solar charging station with 4 charging nodes and 16 panels would cost around 500,000. And microhydro system cost in the range of between 500,000 to 3 million pesos. Geographical location is very important in the determination of the project cost. Since the beneficiaries of BEP are in the remote areas, transportation is a challenge. It may entail cost in as much as the cost of the material itself. Yes, it's true. No, we have a allocation before that the cost of cement is around 200 pesos. When we bought the cement from the end of the road to the community, the cost of hauling the cement per bag is also 200 pesos. So, however, by promoting the sense of bayanihan, this cost is greatly reduced. Another strategy is the work counterparting, where the household members work in the project and part of his or her salary is retained to be paid for the materials to be used in the house wiring of his or her house. Whatever cost is saved becomes the seed money for the Barangay Power Association. The outreach activities of the students and faculty members of the college also help reduce the cost of the implementation. Next is the impact to the student or the outcome for the student. So the students and faculty members were able to conduct 12 activities related to BEP. So this includes training, household wiring, repair and maintenance, installation of powerhouse components, and protection system. So these are the projects that were implemented by both students and faculty of the university. So since in our university, we are also required to do your community engagement. So this program has really helped us in fulfilling that requirement. Next is the research. So student has also conducted research related to the utilization of renewable energy systems. So these researches allow them to comply with the requirement for graduation. So the summary of the researches conducted by students are shown in the table. So this is the researches that were done between 2008 and 2014. However, even though the BEP program ended like in 2014, there are still additional researches that were done beyond this period. So these are just the researches done within the period of BEP program. So how does this impacted the school, the community, and even our center, the CPURF? So for CPURF, to effectively implement the BEP project, the personnel of the center had to undergo training. They were sent to attend resource assessment, PV technician training, microhydro design, turbine design, social preparations, and financial trainings which are conducted locally or international. DOE funded these trainings to enhance the capability of the personnel. International training was held in countries such as Indonesia, China, Germany, and Netherlands, which have expertise on renewable energy utilization. Then for the faculty members, with the training and supervision from faculty members of the department, the students were allowed to participate in 12 activities which resulted in more than 400 households installed with house wiring, 8 microhydro powerhouses installed or rehabilitated, and 6 solar charging stations wired or repaired. Mechanical engineering students were also participated in the installation of turbines in BEP sites. Prior to the participation in any activities, students were trained in the technical aspect of the activity and are allowed to perform these activities under the supervision of faculty in charge. So during the installation, trained community members are paired with students as part of their practical assessment. The student provided guidance and insight to these community members to further enhance their skills in the house wiring installation and troubleshooting. So as you can see here, these are my students installing a transmission line in one of our projects in the province of Aklan. So another challenge in the community engagement of the school is how to convince students to join our activities. However, with the VEP program, recruitment of student volunteer is not a problem. They were made aware that this is an activity in the spirit of volunteerism. Thus, no grade or school credit will be given. However, since they will be working on activities related to their courses, such as in electrical, we do the house wiring for electrical and turbine fabrication for mechanical, they are willing to participate to enhance their knowledge. They also enjoy the trip to those remote places as exhibited by their enthusiasm to join in the next activity. Next is the preparation of budget. So the budget for the outreach activities of the students and faculty members were provided by the CPURF and the university through its University Outlet Center. It is used for the purchase of food for the participants, fare, and purchase of tools and materials. When there is excess in the budget, it is saved for the next activity. As a result, the conduct of these activities is not delayed. This is necessary because the weather is one of the factors in the difficulty of deployment. Because most of the remote areas, it's very difficult to travel during rainy season. Okay, so number 5, point person in charge of the students is selected based on their character. They should put the welfare of the participants on top at all times. They must possess sound judgment to ensure a safe conduct of activity. Prior to deployment, meeting with participants is conducted to discuss the policies and community customs that they need to observe. A proper coordination with the community leaders must be done to ensure that no conflict will occur to ensure the security of the participants. For community, capability building trainings for technical, financial, and leadership were conducted for the BAPA members. If the training is conducted at CPU, the faculty members of the university serve as lecturers. Operation and maintenance was also discussed to ensure the reliability of the electrical system. As a result of this training, the PAPA of the community will only contact the center when the trouble in the electrical system is beyond their capability to repair or maintain. So in other words, they become self-reliant because of the training that we have provided. Then for the students, to further improve the system of VEP, the research areas on solar and microhydro systems are presented to the students. Under the guidance of the CPURIC personnel, the students would undertake their research to comply with their academic requirements. Some notable researches that were done are designed for a solar charge controller, for solar charging station, electronic load controller for microhydro system, asynchronous generator controller, and SMS-based data logger for remote system. So what have we done so far? So in conclusion, CPURIC has influenced the standard of living in remote communities of Panay through the implementation of Barangay Electrification Program, or BEP. While the supply of electricity is limited for these remote communities, the people have experienced some comfort and amenities. With proper training and cooperation, the communities were able to maximize the utilization and benefited every member. In the BEP implementation, a community attitude always plays an important role in the success of the project. It has to be accepted and owned by the community, and the members must be willing to work for it. Self-interest must be set aside, and cooperation should prevail. For the students and faculty members of the college who are involved in the various stages of BEP, uh, they have participated in the assessment, design, fabrication, installation, monitoring, repair, and maintenance and training of the BAPA personnel. So in order to achieve this, training were provided by the college through CPUREC and DOE initiative. This resulted in the gained knowledge and expertise which are then shared to the university. Finally, the budget for the BEP implementation is provided by the Department of Energy. However, activities related to BEP implementation conducted by the students and faculty members are shared by the CPUREC and the university. So any excess budget is saved for the next activity to avoid delays in the implementation. So the participation of students with the BEP activities have resulted in conducted researches related to renewable energy utilization. It has brought awareness and creativity in the minds of the students. In conducting these researches, they have fulfilled the requirements for graduation and at the same time contributed new knowledge on renewable energy system. So I think that's all for the experience of uh, Electrical Engineering Department and Central Philippine University in implementing the Barangay Electrification Program to provide renewable energy source for rural communities. Thank you very much.
All right. Thank you so much, Professor Cesar, for a very elaborate presentation on renewable energy to supply rural community needs. It is very interesting that the project is involving the community and also the students. Actually, I have one question before the questions from the students. Is there any resistance from the community when you are implementing this project?
At the start, you may encounter some resistance because, well, you have to utilize some land area in the community. But eventually, if they understood that the purpose of the project is to improve their welfare, they will just give way into that and they will accept the project.
Yeah.
So
That's
it's
great.
yeah, it's a matter of we call it social preparation.
Social preparation, yes. I can see all the students are also doing their hands-on, doing the project together.
Yeah, so
Everyone is helping each other. Yeah.
So that's one aspect of
Mhm.
the program that
Mhm.
really benefited our students because they can do their hands-on experience,
Mhm.
even though they are just conducting a community engagement.
Mhm. Mhm. Yeah, thank you so much. All right, now back to the Q&A session. I will read the question for Rian from University of Merdeka Malang for Miss Delila. Is it possible for a 3D printer to be assembled and developed by yourself? Do you have experience in developing and assembling a 3D printer yourself? Actually, do you purchase that printer or do you assembling yourself, Miss Delila?
Yeah. Okay, Rian. Yes, I have experience in developing and assembling a 3D printer because my research when I study master degree make a 3D printer machine. Especially I make extruder of 3D printing. The material to make body of extruder from copper. But now I'm in University of Merdeka Malang. I haven't assembled 3D printer in electrical engineering. Maybe next time I will try to make a 3D printer machine for my student. Rian, if you want more about my research about 3D printing, you can read my journals or my proceeding on my scholar because in my journal I explain about my 3D printing when I research my thesis.
All right, thank you so much. So actually you can build your own 3D printer. Is it much cheaper that way? Much economical must be compared to buying the 3D printer.
No, it's more expensive.
Really?
It's expensive. Yes, expensive. Uh, maybe minimum you can one 10 million.
Okay, you use
10
around 10
million
million
rupiah.
Indonesian rupiah, so it's around
Yes.
maybe around $600 roughly for one printer. Okay, now let's move on to the next question from Andriani. How to apply 3D printing for more than one color? Do you need other software or does it just depend on the color setting?
Okay, Miss Andriani, thank you. Based on my experience, I just make one color filament to print 3D object because there are no software or no setting in software if we want to make 2 color or 3 color. So temporarily we just use one color to make one object.
Okay, so temporary, you just use one color first. Maybe later on you can use more color. All right, we have one question for Professor Cesar. What is the most challenging matters for your projects?
Okay, so the most challenging part in implementing any project, particularly if it is a community project, is the sustainability. Yeah. So when you implement the project and you have the cooperation of the community, you can easily complete the project. But once you turn over the project to the community, now the challenge begins with if the community will be able to sustain and maintain the project so that they will be able to use it for a longer time. So most of the time, that is where the failure comes in because there are times that people would look upon themselves and only consider their own benefit from the project. So they will not consider the other people, and then conflict would arise. So that would affect the sustainability of the project.
All right, so it's actually the continuity of the project itself. It's what's the most challenging part. It is not so much about starting the project.
Yeah, exactly.
Yeah,
That's how you the community would be able to maintain it.
How the community will be able to maintain. So to overcome the problems, what normally you do the students and the team keep coming back to the community to check about the condition?
Yeah, most of the time we would organize like an outreach program for our recipient communities to check on them, how they are doing with the project. And also, we would also do some consultation because the community can, through their barangay power association, can actually contact the center if there are problems regarding their project, and they can seek advice and even technical assistance from us.
All right. So it's good that you have the center for the community so they can reach you anytime if they have any problems.
Yeah. And we have project like it has lasted more than 20 years. Even though the grid electricity has already reached the area, they were still able to maintain the project because they see that the cost of the electricity produced in the grid is much expensive compared to the one that they are producing using renewable energy.
Renewable energy. So it's actually renewable energy is actually cheaper compared to the electricity produced in the grid. Yeah, that's great. Okay. So do we have any more discussion or question? Please feel free to type in your questions in the Zoom chat box, or you can also raise your hands. Anyone from our students? All right. So far, we don't have any questions. Okay, so this is actually our last meeting. I saw some of the member of the faculty here. I saw Dean Denny joining in the middle of the class. Thank you so much for joining. We have Professor Krisam, Dr. Laksmi from University of Merdeka Malang, Mr. Subairi, Dr. Dani, Dr. Aris, and Mr. Aang Fajar, and also Dr. Saiful Arifin. Thank you so much for joining, and also to our student and the students from the Central Philippine University. Thank you so much for joining. And do you have any questions or discussion? No? Not so far? All right. If not, then we have come to the end of our session. Thank you so much once again for Professor Cesar for sharing your experience in the renewable energy supply. And thank you for Ms. Delila Cahya for sharing about 3D printing technology. I believe all of our students and also everyone here, even I myself, I also learned a lot during these past few weeks with the 7 classes in engineering, because my background is not engineering, but I've got the privilege to learn about engineering. Thank you so much, and we will see you again soon. Oh, before we end the meeting, I will take picture, a group picture. So everyone, please get ready to open your camera. Can I please have the spotlight removed so we can have all the students? Yeah, thank you so much. I have here Mr. Henry Wiguno, is it, or the student? It's still black, your screen. I'm going to take picture. Can you please? All right. Okay, we have 5 slides here. I will take the first picture. 1, 2, 3. Okay. The next slide. 1, 2, 3. Okay. Next slide. 1, 2, 3. Next slide here. 1, 2, 3. The last one. 1, 2, 3. All right. Thank you so much, everyone. I hope I can see you again soon. Take care. Bye-bye. And have a good weekend. Thank you. Bye.
Thank you. Bye, everyone.
Thank
Thank you
you.
very much. Thank you very
Thank you,
much.
Miss. Dini.
You're most
you.
welcome. Bye. Take
Thank
care.
you.
Prof.
Thank you. Bye.
Thank you.
See you
You.
next time.
Thank you so much. Bye.
You.
Thank you, Miss. Bye.
Bye. Take
Bye.
care.
Thank
Thank
you.
you. See you again soon. Bye.